So for today's topic, we will be discussing about phosphorus industries. Introduction. Hennig Hennig is the first person to identify the element phosphorus in year 1669. Phosphorus comes from the Greek word phos meaning light and phoros meaning bearer, creating the term light bearer. Phosphorus is a solid and exhibits allotrope, meaning it has multiple forms in the same physical state, the main forms being white, red, and black. The major source of phosphorus is apatite, an impure calcium phosphate mineral found in phosphate rocks. Phosphorus, being the sixth most abundant element in living organisms, is one of the most important nutrients needed for survival. It is essential for biological processes and structures that support life, both in plants and animals. Phosphorus is commercially produced for a wide range of applications, including but not limited to fertilizers, phosphate salts, and phosphoric acid. The heavy demand for phosphorus in various fields is vital for the development of low-cost, efficient phosphorus productions. In recent decades, numerous phosphorus businesses have achieved remarkable advances in lowering production costs, allowing phosphorus, phosphoric acid, and its salts to be used in more fields, including the introduction of new derivatives. The three major producers of phosphorus are the US, China, and Morocco. The major types of fertilizers in the Philippines are potash, complete NPK, ammonium phosphate, diammonium phosphate, and ammonium sulfate. Mineral fertilizer makes a significant contribution to the productivity of Philippine agriculture. In the mid-1990s, domestic production accounted for at least 70% of consumption. However, by 2008 to 2010, domestic production's proportion of total consumption had dropped to an average of 12%. The Philippine Phosphate Fertilizer Corporation produces around 1.17 million tons of diammonium phosphate fertilizer annually at its facility. In 200 BC, bird dung was advised and used to boost yields from their respective fields. In Peru, the Incas cherished guano and bird feces such that killing any of the birds was considered a grave offense. In 1842, John B. Lewis received a British patent for the treatment of cancer, which paved the way for the large acid phosphate industry. The two main processes for phosphate industry. The raw material is the phosphate rock raw material from apatite, and it involves the processes wet process and thermal process. In wet process, phosphoric acid produces fertilizers and feed supplements. In thermal process, the white phosphorus produces the phosphorus chemicals. Phosphate rock. Uses and economics. The production of phosphate fertilizer products such as ammonium phosphates and superphosphates is the principal market for phosphate rock. Phosphorus is required for the development of plant roots and aids in the production of larger harvest. Between 2016 and 2021, global phosphate rock production fell by 2.8%. Mainland China and the United States experienced significant declines, whereas Africa, the Middle East, the CIS, and the Baltic states experienced significant growth. Global phosphate rock production is expected to expand at an annual pace of roughly 0.8% between 2021 and 2026. The greatest consumer of phosphate rock is mainland China, followed by Africa and the United States. Raw materials. Phosphorus fertilizer was previously obtained from bones. In the form of phosphorus fertilizers, phosphate rock is now the only raw material available. Fluoropatite, the most common rock phosphate mined, contains impurities like CO3, sodium, and magnesium. The principal apatite mineral in the bulk of phosphate rocks is carbonate fluoropatite or francolite. The presence of francolite in some phosphate rocks contributes to their high reactivity. The United States produced around 33% of the world's rock phosphate, phosphoric acid, calcium orthophosphates, ammonium phosphates, ammonium polyphosphate, and nitric phosphates are only a few of the commercially available phosphorus fertilizers. Processing. Phosphate rock is separated from impurities and non-phosphate elements before being used in construction. Beneficiation, drying or calcining, and grinding are all steps in the fertilizer manufacturing process. The mined phosphate rock is first delivered to the beneficiation operations to remove the sand and clay. Steps vary depending on the type of rock. The phosphate is transported to the processing plant after being separated from the sand and clay. It is then reacted with sulfuric acid to produce the phosphoric acid required for fertilizer production. To convert phosphate rock to phosphoric acid, sulfuric acid is required. When sulfuric acid reacts with phosphate rock to make phosphoric acid, calcium sulfate or gypsum is formed as a byproduct, and it is also known as phosphogypsum. This figure illustrates the phosphate rock process. Superphosphates. The first chemical fertilizer was superphosphate. It was first made in about 1840 from bone meal and sulfuric acid. Superphosphate is manufactured from the reaction between sulfuric acid and phosphate rock. This material is called the ordinary superphosphate, sometimes known as single superphosphate. Triple superphosphate or concentrated superphosphate with a grade of 0.460 and no sulfur is produced by treating rock phosphate with phosphoric acid. Today, almost all superphosphate is triple superphosphate. Superphosphates provide phosphorus in the form of monobasic calcium phosphate, which is soluble enough to feed crops. Ordinary superphosphate contains gypsum, which dilutes the monobasic calcium phosphate concentration. Manufacture. The acidulation of phosphate rock to produce superphosphate has been the most important method of making phosphate available for fertilizer purposes. The reactions occurring during the production of superphosphate are complex and are usually summarized as follows. So here are the reactions that occur during the production of superphosphate. Figure 1.3 illustrated the flowchart for the manufacture of superphosphate. The three-step process of manufacturing superphosphate. Step 1 is the phosphate rock blending and grinding. In step 1, the amounts of phosphate, fluoride, and silica in phosphate rock vary depending on the source. In the blending facility, these rocks are combined to form a product with a total phosphate content of 15%. A hammer mill is used to decrease the particle size of the phosphate rock. After that, the coarsely ground rock is processed through an air-swept roller mill to achieve a rock grease of approximately less than 75 microns. In a big hopper, the powdered rock is kept. A dust collecting system is included with a power handling system. Step 2. The superphosphate manufacture. In superphosphate manufacture, phosphate rock, sulfuric acid, water are mixed and then allowed to dry and react to give the superphosphate a mixture of granulation. The cake of superphosphate is then ground to give particles no more than 6 mm in diameter. A pulverizer, granulation drum, and classifier make up the granulation circuit. Before the product is fed to the granulation drum, the pulverizer breaks up any lumps. The superphosphate is rolled and agglomerated in the granulation drum to generate granules. The retention period and bed depth are determined by the drum's inclination and feed rate. The granules exit the drum at the end and travel through a classifier. While the completed product is delivered to the product stores, oversized grains are recycled through the drum via the pulverizer. Triple superphosphate. This fertilizer is substantially more concentrated than standard superphosphate, containing 45 to 50% of accessible P2 phosphorus pentoxide, or roughly 3 times the quantity in regular superphosphate. The action of phosphoric acid on the phosphate rock produces triple superphosphate and no diluent calcium sulfate is generated. Ammoniated superphosphates. Ammoniation of superphosphate, triple superphosphate, or combinations results in fertilizer with desirable chemical stability, textural consistency, and moisture resistance. This has been proven to be a successful method of presenting nitrogen into fertilizers that are ready to use. An excessive amount of uncombined ammonia added to the superphosphate causes phosphate reversion, resulting in insoluble phosphate forms. As a result, in current ammoniation practice, nitrogen solutions comprising urea or ammonium nitrate are recommended. Calcium metaphosphate. Calcium metaphosphate is developed from phosphate rock, a concentrated fertilizer. Wet process phosphoric acid. Use and economics. Rapid expansion in the manufacture of wet processed phosphoric acid has resulted from the increased demand for high analysis fertilizer, triple superphosphate, ammonium and dicalcium phosphates. The majority of phosphoric acid was previously made by reacting dilute sulfuric acid with crushed phosphate rock or bones. The Doer-Strong acid procedure has overtaken this approach. This results in a stronger, less expensive, and purer acid. The equipment should be lead-lined, and there should be enough time in the agitators for the reaction to finish. The digester should be kept low enough to ensure the precipitation of gypsum. If the latter is created, it will hydrate later and pipes become clogged as a result. Acid made by this process is almost entirely used in fertilizer production, where impurities are unimportant. Pure acid is obtained by the electric furnace process. Manufacture. The chief process for producing wet processed phosphoric acid is by the use of sulfuric acid. The essential reactions are the following. Figure 1.5 is an illustration of a wet processed phosphoric acid manufacture using bird prey tilting pan washing fillers. Purification. Crude wet processed acid is often black and contains dissolved metals and fluorine, and dissolved and colloidal organic compounds. Suspended solid impurities are usually removed by settling. Solvent extraction or solvent precipitation is used to remove the dissolved impurities. Solvent extraction uses a partially miscible solvent, such as N-butanol, isobutanol, or N-heptanol. The phosphoric acid is extracted and the impurities are left behind. Electric furnace phosphorus and phosphoric acid. In 1920, the electric furnace technique was first used commercially. Because the slag takes away impurities, this procedure allows for the use of lower grade rock than the wet process. Because of the improved CaO balance for slag formation, lower grades are typically favored. The most important requirement is low-cost electricity. The phosphate rock has to be charged in lumps. Fine material tends to obstruct the escape of phosphorus vapors and create bridging and then even fall to the furnace charge, resulting in puffs and excessive dust and create carryover. Phosphate lumps may be prepared in the following ways. Pelletizing by tumbling or extrusion, agglomeration by nodulizing at high temperatures, sintering a mixture of phosphate fines and coke, and briquetting with the addition of a suitable binder. After agglomeration, coke breeze and silicon flux or gravel are added and the material are charged to the electric furnace. Figure 1.7 is an illustration of the phosphorus production flowchart. Phosphates. Phosphates play a vital role in biological systems as a structural substance of bones and teeth. In dental enamel, these structures are comprised of crystalline calcium phosphate in the form of hydroxyapatite. Phosphorus is a nutrient that is necessary for plant growth. Root development, plant maturation, and seed development are all aided by it. Phosphorus is one of the most crucial elements for plant life, alongside nitrogen and potassium. Sodium phosphate. Sodium phosphate refers to a group of sodium and phosphate salts. Phosphates also come in the form of di, tri, tetra, and polyphosphates, which are all condensed anions. The majority of these salts are available in both anhydrous and hydrated forms. Hydrates are more prevalent than anhydrous forms. Sodium phosphates are commonly employed in baked goods as emulsifiers, thickening agents, and leavening agents. They are also used in medicine to treat constipation and prepare the bowel for medical operations. They are also utilized in detergents for water softening and as an effective anti-rust treatment. So here is a diagram of a plant for the manufacture of a crystalline sodium polyphosphate. Pyrophosphate. Phosphorus oxyanions with two phosphorus atoms in a POP linkage are known as pyrophosphates. There are several pyrophosphate salts including disodium pyrophosphate and tetrasodium pyrophosphate. Pyrophosphates are frequently referred to as diphosphates. These compounds have been widely employed in industry due to their ability to prevent calcium carbonate precipitation. For calcium phosphate is a calcium and phosphorus containing chemical. It is a naturally occurring mineral that's found in abundance in bones and teeth. Some people may benefit from supplementation since the chemical has a number of activities in the body. Baking powders. Phosphate rock is used extensively in the baking powder industry. Leavening agents have been used to promote aeration and lightness in bread and cakes since the time of the Egyptians and have been passed down through Greeks and Romans. Monocalcium phosphate monohydrate, anhydrous monocalcium phosphate, sodium acid pyrophosphate, sodium aluminum sulfate, tartaric acid, and acid tartrates are the most common baking acids. Monocalcium phosphates are eaten in greater quantities than any other, with an estimated consumption of 78 million pounds in the United States on a yearly basis. The active chemicals are frequently supplemented with a filler or drying agent such as starch or flour to make the dough more evenly distributed and to act as a diluent or may function as a deterrent to the process until water and heat are added. Fire retardant chemicals. Phosphorus flame retardants are a diverse group of additives and reactive organic and inorganic chemicals that are used to increase the fire safety of combustible materials such as plastics, textiles, wood, paper, and other flammable materials. In commercial practice, the chemistry and mode of application are given special attention. Epoxy resins and polyesters, which have built-in phosphorus structures, are being studied. Commercial trends as well as health, safety, and environmental issues are explored. Textiles, plastics, coatings, paper, sealants, and mastics all use phosphorus-containing compounds as flame retardants. Organophosphates, phosphonates, and soluble and insoluble inorganic phosphate salts are all on the list. There are other phosphorus-containing halogenated materials. Char formation in the case of inorganic polyphosphonates and free radical inhibition in the case of certain organophosphates are two examples of various methods used by different compounds. Phosphorus can be found in a variety of fire retardants and fire protection materials. Steel and building components as well as intumescent coatings and sealants can all benefit from ammonium polyphosphates. Ammonium phosphates, usually orthophosphates, are commonly found in domestic fire extinguishers. So that ends the report about Phosphorous Industries.